All right, let's see if we can answer these questions based on what we learned. In number 2, it says, in which quadrant would the terminal ray of an angle drawn in standard position fall if the angle measures 860 degrees? So what we have to realize is that 860 is way more than 360. In fact, guys, 360 degrees plus 360 degrees is only 720 degrees. So we have to realize that not only did we go twice around, but then we also continued to keep going around for another 140 degrees in order to get it to 860 degrees. All right. So I'll show you a little visual, but here is my initial ray. And my path would go up and around, not only once for the first 360, twice for the second 360, and then 140 degrees more, which is about right here. Okay, and so we ended up in quadrant 2, and now we can pick our answer. Okay, so a little bit tricky. All right, how about number 3? Give a negative angle that is coterminal with each of the following positive angles. Okay, so let's go ahead and put in our vertex and our initial ray for all of our graphs. And they want a negative angle that's coterminal with each of the following positive angles. Okay, so let's go ahead and think, we're 90 degrees. This would be the terminal ray for an angle that measures 90 degrees. And so 90 degrees would go up and around. They want a negative angle, which means we have to go down and around. So how far did we go down and around to meet up with it? Well, because we went down, that's a negative angle, and we would have to travel the rest of the circle. So if you think 360 minus the 90, we travel 270 degrees. All right, and that's the negative angle that is coterminal. Notice it ends in the same exact spot, okay, with each of the following positive angles. All right, so hopefully that makes sense. We're going to do it 3 more times. So 330 would be, let's see, 90, 180, 270. That would be 360, so it's somewhere in here. So that if I go up and around, that would be 330 degrees. I want a negative angle, so I have to go down and around to meet it. How far did I have to go down? Well, because I went down and around to meet it, it's negative. And I would have to go just that little part left to make the full circle of 360, so it would be 30 degrees. Okay. Part C, my angle is 120, so if I go up and around, that'd be 90. Keep going, that'd be 180, so not quite there. Let's say somewhere in here. Okay, so that if I go up and around, that would be 120 degrees, but I want a negative angle, so I have to go down and around to meet it. Okay, so if you think 360, take away the 120, because I'm going down and around to meet it, it's negative, and it would be 240 degrees, because 240 and 120 would make the full circle around. Okay. Next one, 210. So up is 90, across there is 180, down is 270. So somewhere in here, that if I go up and around, this would be 210 degrees. I want a negative angle, so I have to go down and around to meet it. So it would be negative 360, take away 210 is 150 degrees. And there they are. So that's coterminal. Okay, so if I were to take away these little drawings in here, if I were to take away this information here, if I could take that away there, I can scribble it out. All right, so if I were to take away this information, okay, and that information, and I just drew you the blue arrow and the red arrow, one might say the answer to how many degrees are in that angle is 210, but somebody else might say, well, I'm going to go down and around. I could say it's negative 150. The picture would look the same. The arrows would be in exactly the same spot, but the angle would measure 2 different measurements. All right, and that's coterminal. So next part up, we're going to talk about reference angles. Okay. So for each of the following, draw a rotation diagram and then state the reference angle. All right. Reference angles have to be positive and acute, meaning that their measure has to be between 0 degrees, okay, and 90 degrees. Okay, it can't be 0 and it can't be 90, but somewhere in between there. And so our reference angles lie in quadrant 1. Okay. If you want a quick way to get the reference angle and you're in quadrant 2, that would be 180 degrees minus your angle. Okay. In quadrant 3, that would be your angle minus 180 degrees. And in quadrant 4, that would be 360 degrees minus your angle. All right. So if you remember this, that it's the quickest way back to the x-axis. And it might make a little bit more sense if you think that way. Okay. So here we go. In part A, we have 210 degrees. Okay, that's our angle. So we'll go ahead and draw in all of our vertexes and our initial rays for each one. Since the vertex is always at the origin, initial ray is always on the positive side of the x-axis. Okay, so now where's our terminal ray? For 210 degrees, it would be somewhere down here. So that this angle is 210 degrees. But if they want to know my reference angle, it's the quickest way back to the x-axis. So we have two ways we can get back to the x-axis. We can go to the negative side of the x-axis, or we can go to the positive side of the x-axis, as long as we're back to the x-axis and you want it to be the quickest way. So we are going to have the quickest way go back up to the negative part of the x-axis. So they basically want to know how many degrees, what would your angle be that you would have to travel to get back there. All right. And so since this is 180 degrees on that part of the x-axis, we want to go from 210 back to 180. And so that means that I would have to travel 30 degrees. And therefore 30 degrees would be my reference angle. Notice it's positive, it's acute, and traveling 30 degrees back to the x-axis would make that my reference angle because it would be the quickest way back. All right. So a lot of people, if you think about what we did and talked about up here in quadrant 3, that's really just 210 minus 180, which is the quickest way to get to 30. All right. If you want a quick way of thinking about it. All right. Part B. Part B, we have 345 degrees. So we got 90, 180, 270, 360. So it's somewhere down here. So that if I traveled up and around, that would be 345 degrees. Now, because they want the reference angle, it's the quickest way back to the x-axis. You can either go to the positive side of the x-axis or the negative, but remember you want it to be the quickest. So all I have to do is travel a few more degrees up and I would be right back on the x-axis, the positive side. All right, how many degrees would I have to travel to get there? I would have to travel 15 degrees because 345 plus 15 would put me at 360 and I would be back on the x-axis and that would be my reference angle. Notice it's positive, it's acute, okay, and it would put me back on the x-axis the quickest way. All right, and so again, if you think about what we talked about up here, that to get that reference angle, you take 360 and you subtract your 345. Okay, that's another way you can get that 15 degrees. All right, part C, 112 would put me right about here. This angle would be 112 degrees. They want to know the reference angle, so they want the quickest way back to the x-axis, and so that would be going down a few more degrees there to get back to the x-axis. All right, so I would have to travel 68 degrees to get there, and that would be my reference angle. Okay, again, if you want a little trick, look up, and what did we talk about there up there? So it's 180 if you're in quadrant 2. Take away your angle, and that is your quickest way to finding that 68 number. Okay. Part D. we have 605. All right, so what we have to realize is that that's 360 degrees plus 245 degrees. So we traveled all the way around and then 90 more, 180 more, but not quite 270. So we're going to say that it's around here. So watch my rotation. So it's up and around for the 360 and then 90, 180, and all the way to 245 degrees more. So that is a rotation of 650 degrees. Keep in mind what they wanted to know. They wanted to know our reference angle, which is the quickest way back to the x-axis. So we want to go back up this way. All right. So if you think we're down in quadrant 3 there. All right. And so if we go ahead and take our 245 and we subtract our 180 from it, we'll realize that we had to travel back up 65 degrees, and therefore 65 degrees is my reference angle. Okay. Part E, negative 160 degrees. Okay, so that would be down and around and not quite to negative 180. So I'm going to say around here. So that this is negative 160 degrees. And I want the quickest way back to the x-axis because they're asking me about the reference angle. So hopefully you realize all you have to do is travel 20 more degrees to get back to your x-axis. And so 20 degrees would be your reference angle. And some people will say, is it a negative 20? But remember, reference angles, guys, have to be positive and acute. Okay. So you don't have to worry about what direction you're traveling, just how many degrees you are traveling. Okay. Part F, negative 78 degrees would put us down here. So that this measurement down and around is negative 78 degrees. And keep in mind that we want a reference angle, which is the quickest way back to the x-axis, would be to travel 78 degrees. And that would be my reference angle. If I traveled 78 degrees, I can get back to my x-axis. Okay. All right, part G. They want negative 280 degrees. So that's down and around and slightly right into quadrant 1 here. So again, watch my rotation. Down 90, negative 180, negative 270, and a little bit more would put me at negative 280 degrees. Okay. Keep in mind they're asking about a reference angle, which is the quickest way back to the x-axis. And so to get back to my x-axis, the quickest way would be to take that angle where I stopped and go down to the positive side, which means that I would have to travel the full circle. All right. And I would just have to kind of travel, what do we got there? 80 degrees more. Okay. So if I travel 80 degrees down, it would put me right back on my x-axis. And so 80 degrees would be my reference angle. All right, part H. We want to travel negative 410. So that's negative 360 degrees and 50 degrees more. Okay, which would be negative 410. So I'm going to go all the way around and then 50 degrees more. So it's going to put me somewhere around here. So that this is negative 360 and then 50 more. So this is negative 410 degrees. All right. Remember, they're asking for a reference angle. Quickest way back to the x-axis would be to travel back up to the x-axis, which would be 50 degrees. And that's my reference angle. All right, so hopefully that helped, guys. And I will see you on the next day of notes for some more practice.